All right, let's go ahead and get started. Hi, everybody. How are you doing today? Doing well? Everybody happy? I imagine at this point you all have had a chance to look at the assignment and you're curious and you have questions about it. So, this is your opportunity to ask questions about the assignment. Any questions? No? Moving on. Oh, you have a question. Yes. When you read the input file in this program, every column will always be in exactly the same order. Okay, you don't have to read the header to figure out what order the columns are in. The headers are just there, in essence, because like when you get data files from people, oftentimes they have headers at the top so that people know what columns each one is. Does that make sense? And you're going to have to look at the file and get rid of the header because you don't care about it. Yes. Each column, the file format is set. Each column will always have the same set of numbers in it. Like I don't remember the format off the top of my head, but the first one's always going to be age, and the next one's always going to be pumpkin density or whatever the name of the column is. Always. There will be no format problems with the text file. I'm not going to have a column of numbers that suddenly has a character or a string in it. You don't have to worry about that. You do have to worry about range checking. Like the values in the file may be out of range. It will always be 7 numbers across. There will always be one header line at the top that has the names of the columns. The thing that you don't know are how many subjects in there. There might be 4. There might be 10 million. Every line will be full and complete. The numbers in that line may not be reasonable, okay? But every line will be full and complete. Yes? Nope, it's not. Yes. We will get to everything you need for the programming. Today's Tuesday. We will get through it by Thursday. So you will have at least a week with the programming part. Does that make sense? But we're going to do how to open and read files today, for sure. Yes? Good question. What do you think you want to do? What does my program do? Mine skips the line. So have yours skip the line. But you should definitely warn people when you're skipping a line, right? Because you don't want to like skip a whole bunch of lines and then not tell anybody about it and give them the wrong result. And then they go off and do science on this and come up with a whole bunch of treatments, and then people are not as healthy as they would have been otherwise with the additional data. So, or a whole bunch of people die or something. Other questions? Now, one thing you might be wondering is how to show in your algorithm how to read many lines of code. Does that make sense? Essentially, what's going to happen is that when we have all of these lines, each line is going to have a bunch of numbers, right? And I have no idea if I'm writing valid numbers or not, but there's 7 different numbers, right? And what's going to happen is there's going to be multiple lines just like this, but we do not know how many lines there are going to be. Okay? We just don't know. So for your algorithm, it's acceptable to say something like while lines left, right? You can say something like that that indicates while there are more lines left. And then you have something that, and then you have something you just read one line. And this is essentially how our algorithms would work, is we're going to check if there are any lines left. We will read one line, which actually means reading seven different data values. You do some computation on them, and then you go back up, read the next line. Yes, sir? Yeah. Sure. Yeah, that sounds fine. That sounds fair to me. Check the grading rubric. The grading rubric was posted last night. It was posted through Facebook, and there's a forum, like a discussion forum, dedicated to the project. And I believe at least it was posted on there. And yes, I'm old. Every single part of social media is all Facebook to me. no matter what it is. You know, that Facebook for professional people, and yeah. I'm going to keep making that mistake throughout the semester. I guarantee you in here I'm never going to talk about Facebook. Just say when Clay says Facebook, make it Facebook, right? Blackboard. Yes. We will talk about accuracy, if not today, on Thursday. Mine gets down to 2 decimal places. The computer will carry an arbitrary number of decimals. No, you don't need to worry about using a long. I used a double for mine because just in general, when I use floating points, I use double. Yep. You should implement the formula that's in there. The order of operations may or may not have a significant effect, right? But we talked about order of operations for math, didn't we? So you should know what order to do them in. Has everybody looked at the equation? It's big, right? There's a lot of different pieces to it. All right, other questions? Yes, sir. Nope, it should say error in line 3 of data, and then it should print out the ones that are correct and the average over the ones that were correct. That may or may not be the way you would do it in the real world. That's how I wrote mine. So. Yeah. I mean, you can't tell if the line was bad or not until after you read it, right? Yeah, that's what you're going to be doing. You're going to work on each line separately, right? Your algorithm is going to take input, one line, do some calculations on it, and then go to the next line, read the next line, do some calculations on it. If the third line had an error, it would output the first 2 correctly. It would say error in line 3, whatever out of range. It would then do line 4, and that would show the average over the correct lines. Which, by the way, as I mentioned that, there's a bug in my program. I will fix it later. I just realized that. All right, other questions? So right now, don't trust the average on my program if there's an error in the line, because the average will be wrong. I will fix it tonight and give myself a candy bar for realizing that I had a bug. So. Other questions? Going once, going twice, 3 times. Okay. So last time, we talked the entire class about strings. And I apologize, I normally put the raw video up. It is uploading to YouTube right now as we speak. I accidentally left it on campus and I couldn't get access to it over the weekend. So it's uploading now. It'll be posted later today as soon as YouTube indexes it and I can put it into Facebook, which means Blackboard. Okay. So it'll be posted as soon as I can get it up, probably later this afternoon. What is a string? Something you tie your shoes with? Something you go fishing with? Yes? Yep, it's a whole bunch of characters put together. They might indicate words, they might indicate a sentence, they might indicate random stuff, but a string is a whole bunch of characters that are jammed together. We talked about how to assign things to a string. How can we do assignment to a string? Pardon? Dot assign is one way, and what way is that? That's called a method. A method has something that has a dot and a word after the variable name. We can use dot assign. We could use other things as well, such as the equals sign, right? Equals works just like we did before. We talked about input. We talked about using cin and getLine. What does getLine do? Yes? It reads the whole line at once, all the way until it reaches like the end of the line. There's a hidden marker called end of line on there. That's like the return on a typewriter. And when I'm teaching this class in 20 years, no one's going to know what a typewriter is, and I will have no analogy. So it's like a return on a typewriter. CN breaks up input into small pieces and reads each one individually. Okay? So if you want to read a whole line at once, somebody's name or something that you don't know how many pieces it's going to have, which one do you use? Yes, get line. I was trying to throw you off. And if you're reading something that's in a precise format and you know how many different pieces it's going to have, what do you use? All right, everybody good on that? That's going to come into play for the project. We're going to take a little bit of a deeper look at CN today because it's fun and does some bizarre things. We talked about appending things to the end of the string. How do we append things to a string? Dot what? Dot append. And what's that dot thing called? A method. And what other ways can we append things to a string? The plus sign, which also does appending. So you can construct strings out of pieces by appending them together. We talked about methods. What is a method? I haven't given you a formal definition of it, but for a string and for some other things that we're going to be seeing, you can do the variable name and then dot something with parentheses, and it has some intrinsic functionality built in. Okay? So for a string, what methods did we talk about? We talked about append and assign. What other ones did we talk about? Length. What does length tell you? How long it is measured in what? Inches? Characters, right? So it tells you how many individual characters are in the string. If you want to access one particular character in the string, you use at. What is the devious, tricky little trick with at? It starts counting at 0. So if you have a string and you ask the string its length using the .length method, it will tell you how many characters long it is. It might say, I am 6 characters long. And those characters are numbered from 0 to 5. Okay? So even though the length is 6, it numbers 0 to 5. And what happens, we experimented this, if you go beyond the length of the string with at, your program crashes. Your program crashes. Okay? We talked about substring. What does substring do? Yeah? Right, so if you have a long string and you want to clip out just a little piece of it, you can use substring. You tell it where to start and how many characters. When you tell it where to start, how is that numbered? Starting at 0. All right, that's the nutshell, I think, of everything we did last time. So, we should be able to use strings, and now we're going to start looking at a little bit of weird behavior on the part of input, particularly CN. So I wrote this program before class. For some reason, this projector clips off the left side, so let me move it over where you can actually see it. Okay, so here's our program. Same stuff at the top. Pound include IOStream. What is that? A library, yep. Using namespace standard is, it's just magic. We don't care. Int main. What does int main do? Tells us where to start. Okay, so let's just step through this program and see what we have in here. int1 equals 12. What does that do? Declares a variable of type with a name and initial value of? Excellent. int2 declares a variable of type with a name, value, initial value. Okay. Double decimal equals 37.92, declares a variable of type double, the name decimal, initial value 37.92. And then char is what? Char? It's a single letter, so we declare a variable named letter. That's a character type that is initialized to x. Okay. So we've declared some variables, we've given them some initial values, and there we are. Now the very first thing this line does is it says, hey, input an integer, a letter, a decimal, and another integer, and put them in these variables that we defined above. Make sense? We're going to input something in integer, then letter, then decimal, then integer, And then all we're going to do is turn around and print it out again. Print out an integer, a letter, the decimal, the other integer, and the end of line. Pretty simple? Yes, sir. Oh yeah, return 0. Thank you. All right, return 0. No, these quotes are just to put spaces between things when they print out, so that they don't all print out jammed together, and we can see which value is which. So, okay. All right. Yes. It's taking some input and then it's outputting. That's all it's doing. We declare some variables. We give them an initial value. We input things into those variables, which should overwrite the values that we have in there. And then we output what we got. That's it. That's our whole program. Now the question is, why the heck are we doing this? Is that really what you're asking? Say yes. Yes, you're asking, why are we bothering to do this? I mean, we already have some values. We're inputting some stuff and we're outputting some stuff. We are doing this because I want to show you that CN is not your friend. Okay? CN works great when it works, but CN is also slightly insane. And CN, on occasion, will do things that are kind of bad. Okay? And I would like to demonstrate these things to you so that you understand them, and then I can write really hard exam questions, and when your program starts doing weird stuff, you will understand why. Okay? So this is to demonstrate CN's great. CN's a great friend of mine. We love him dearly, but on strange occasions, he does weird stuff. Okay? Do you all have friends like that? You probably will eventually. Okay, so let's see what's going on here. We'll compile this and see if it runs. Oops. And I was doing a little bit of testing before, so I'm pretty sure it will compile. So I compiled this program, and now we'll run it. Now, one thing I didn't say is print out is like what we're asking for, and there's a reason for that. The reason is we're going to show you what goes wrong when you enter a variable of the wrong type. Remember before I told you never had to worry about type errors? I'm going to show you now what goes wrong when you think. So, if we go back to our program, it's asking us for an integer, a character, a decimal, and then another integer. So let somebody give me an integer. Somebody give me an integer that's not already in the program. 14. Somebody give me a letter. H. Decimal number. 0.2. And another integer. 3. And look, it read an integer and it outputted the integer. That went well, didn't it? It read the letter and outputted the letter. Did that go well? That went well too. It read a decimal and output a decimal. It put a 0 in front of us. We omitted it, and that was fine. It figured it out. That went well. And then it outputted another number. Thumbs up. Let's try it again. This time, let's take out some of the spaces. Let's try this. Let's try 14H space 0.2 space 3. Any predictions on what's going to happen here? Any guesses? Yes? Nope, I don't think so. It might, but not that I'm aware of. I don't know. How many of you think this is going to crash? How many of you all think it's going to output everything correctly? How many of you aren't really sure? Yeah, there's no reason you should know this. It's going to output everything absolutely correctly. Yeah, what? What? That is unexpected. Here's why. CN is going to do its very best to figure out what the heck happened with your input and try and correct mistakes. Okay? So, this one was 14H.2 and 3. So, here's what happened. It said, okay, I am inputting something into an integer. What do we know about integers? What kinds of things are in integers? Are there question marks in integers? Are there H's? So what CN looks and says, okay, I'm expecting an integer. I'm just going to find the longest series of integer-like numbers I can. And what was the longest series of integer-like numbers it could find? 14. So it goes, okay, 14. Now I'm expecting a letter. Is H a letter? H is a letter. So it goes, okay, I'll put H in there. And the decimal and the int2 were just like we saw before. Yes? Uh-huh. Yes. That's exactly what happens. It has this initial value. And remember, it's just a big machine that stores numbers in boxes. It put 12 in that box. And then the first time we did input, we said, hey, that box, remember the one over there with this name? I don't care what's in there right now, but stick 14 in it. There is a reason for these numbers, which will become apparent shortly. Okay? Yes, sir? Okay. Well, CN is breaking on spaces automatically, but if the spaces are not there, it will do its best to figure out what's going on. Does that make sense? Yes, sir? We'll try some other stuff. Okay, so everybody saw what happened there. CN, if it tells that there's two different types, when it looks, it tries to find the longest sequence it can that matches that, right? So it was able to say, oh, 14, and then H must go in the letter, and off it went. Yes? We're going to get to a whole bunch more what ifs. I tell you what, can you hold that until after I've shown you some other stuff? Is that okay? Because we're going to do a bunch of other stuff now. Okay, let's try something else. Somebody give me an int. 8. Somebody give me a letter. 8. Is 8 a letter? Yes, it is. It's a character. There is a character for the number 8, right? It's a single typographical symbol. It's a character. Come on. All right, I'll do this over again. Ready? Somebody give me an integer. 8. Somebody give me a character. 8. Good. See? Now are you happier? Now it's not a letter, it's a character. Is 8 a character? Everybody should be saying yes. 8 is a character. It represents an integer, but to the computer, this is going to be an integer and this is going to be a character. They're actually very different. Yes? Yes, it can only be one number. Only, because a character can only be one symbol, right? How many people did I just really completely confuse? Yeah, right? So the computer has inside a box set aside for these things, doesn't it? We can go up and look at it this really fast. So int1, this is a box of type, and it has a name, and in there is a, this box has a type, and it has a name, and in there is a, well, it turns out that these characters can be anything that we can type on the keyboard plus some other weird stuff that we never worry about. Can you type an 8 on the keyboard? I guarantee you can. I just did it, right? So if you put an 8 in here, if you make this an 8, if you have a character store a number, a single number, it is confusing to you because you think of numbers as numbers no matter how they are, but the computer will look at this and go, oh, it's a character, it's the symbol 8. Do you remember that lookup table I showed you before? Behind the scenes, there's that ASCII table, and there's a special code number for 8, just like there is one for X. So it is perfectly happy with you sticking a single number in a character. Now here's what you cannot do. You cannot add an integer and a character that has a number inside and expect to get sane results. You will get insane results. It will probably work. I don't even want to try it, but it will probably work. Okay? But the answer you get would be just odd. Well, or even, but wrong either way. Okay. All right, who's with me, sort of? Who's against me? He's missing today. About adding? Okay. I'm going to write a whole separate program just to show you this. How's that? Here's what we're going to do. We're going to have an int. Somebody give me a name, number. Somebody give me a value, 12. We're going to have a character, which is a number symbol, which is equal to 8. All right. Is this going to compile? How many of y'all think it will compile? How many of you think it will not compile? Why will it not compile? Because a character always needs single quotes around it. So, allow me to demonstrate. This is not what I intended to be doing, but why not? Oh, you're killing me. All right, let's just pretend we had marks around there. I don't know why that compiled. Yeah, probably. I don't even know what happened. We're not even going to look. Okay, but let's see this. So a number and a character, okay? If we want to output these things, we can output them. Okay, so here's what we're going to do. We're going to output the number. Where did my cursor go? We're going to output the number. We're going to output the number symbol, and then we're going to add them together and see what that is. Who's feeling brave? I'm glad you are, because I have no idea what this is going to do. So anybody want to predict what this output is? Number plus number symbol should be, how many of y'all think it's going to be 20? How many of y'all think it's going to be somewhere in like the 60s? I'm guessing 60s? 70s. I'm going from 70s to 80s. 70s to 80s. That's what my guess is, okay? I actually don't know what it's going to be because I didn't think to do this before class. 68. I was a little off. Okay. Now you're asking yourself, what the hell just happened, right? There is absolutely, positively a difference between an integer and a character. A character is just a code number that represents that symbol that your mind, not being mechanically oriented like a computer, interprets as a number. The computer does not care that this symbol represents a number. Yes, sir. I don't know. Why don't you try it at home and tell me what happens? I don't want to go down that rat hole right now. Okay, so it's 68 because we also had this ASCII table, which I got rid of. Let me bring it back really fast, and I'll show you why it's 68. I didn't really want to spend time doing this, but, you know, once you open the box, you might as well find out what horrible things are in it. All right. So if we look up the ASCII table, the number for 8 right here is actually code number 56. And so when we did the addition with 56 and 8, it added 8 to 56 and got 64. Because a character is not really a number. Just because it's a symbol that represents a number, it's still a character. And it still does weird things. Okay? So, rule of thumbs, don't add characters. If you have a number that's a character, don't expect it to act like a number. Does that make sense? And I was trying to guess where this was. I thought the numbers were actually between the uppercase and lowercase, and it wasn't even close. So anyway. All right. Does everybody sort of understand this? There is a huge difference between characters and numbers. Yes, ma'am. It just might happen someday, right? It just might happen. Like a compelling use case might be if you had like a menu of options, right? And they were numbered 1 through 8, you might read them as characters. You might have a mixed menu, which is like A through Z, 1 through 8, or something like that. That's the case where you might have that. Okay, everybody kind of okay with this character and integer stuff? Yes, sir. Yes. If you do any math on characters, it will always use that code. The rule of thumb is don't do math on characters. There are very specific circumstances in which you will do that, but they are not something we will do in this class. Okay. All right, everybody good right now? Here's what I'd like you to do. Take a minute, shake, stretch out, whatever you need to do. Stand up, scratch your head, take a 1-minute break. Yes. In fact, that's a very common operation, and there's special libraries that do that. So. You have 2 seconds, yeah. Yep. No arrays. You don't need arrays for this assignment. All right, welcome back. How was your minute? You feeling better? All right, let's move away from this abomination, which is adding characters to integers. Just know that this is bad. Does everybody agree this is bad now? It's bad. We'll just get away from this. And we'll go back to looking at input. Now, if you remember, we were talking about doing input into an integer, then a character, then a decimal, then an int. And we realized that if we had 14 and x together without a space between them, CN was fine with that. Wasn't it? Yes? All right. So getting back to what I was showing you before, we will try and do input. We need an integer. Somebody give me an integer. 8. Somebody give me a letter. 8. Somebody give me a decimal number. 0.2. Somebody give me another integer. 2. All right. This went fine. It read it as an integer, output as an integer, read it as a character, outputted it as a character. Can you tell the difference looking at the screen whether the computer stored that as a character or as an integer? That would be awesome if you could. You would make a huge amount of money reverse engineering other people's programs if you could look at the screen and understand what was going on inside by the output. I can't do that. All right, so here I am. Okay, so 0.2 gets read and goes into 0.2, and the other integer comes out as an integer. Now, last time we saw when we put 14 in H, it split it apart, right? Pardon? I don't know. You want to try it? 8, that's the integer. That's the character. 0.2 and 2. Want to try that? Oh, man. So here's what happened, right? CN was expecting an integer, a character, a floating point number, and another integer. And it did its very best. It looked at this big mess and it said, oh, man, what is the longest integer I can make out of that? 880. So it goes, okay, 880 is an integer. Now I'm looking for a single character. What is a character? Point could be a character, can't it? Yeah, so that's a character. And it says now I'm looking for a floating point number. What's the longest floating point number I can get after that 2? 2, and then the other integer is 2. So CN is always going to try and parse the input matching what it is given. And it will always try to make the longest thing it can out of what it's given. Yes, sir? Okay, so everybody understand what just happened? Thumbs up if you understand. Okay, good. That's mostly thumbs up. So the question was, what happens now if we take out that space there between the 2 and the last 2? Because I'm throwing them in there because I know what's going to happen. What if we do 880, or 8, then integer 8, what we expect to be a character 8, 0.2, and then an integer 2? What's going to happen now? All right. If I put enter, The prediction is it's not going to output anything, which is correct. Because here's what just happened. It now thinks, it's now done its best and says, okay, 880 is the integer, point is the character, now 22 is the float, and we need to give it one more integer for it to be happy. And so it doesn't do anything because it's waiting for that last integer. So let's give it an integer, and now it's happy. All right? Yes. Yes, it does. All right. Everybody kind of happy with this so far? In this case, it hung because we did not give it enough things, and it was waiting for the last input it needed to fill out everything it was expecting. Yes? Yep. No. I told you the file format's going to be clean. It's going to be perfect. You don't have to deal with this stuff. Where you have to deal with this stuff is when you're dealing with people, because people range from imperfect to suck, right? So, yes? I'll show you in 1 second. Okay? All right. So you see what it's trying to do here, right? You see what it's trying to do here. It's trying to make the longest thing, and I will get to your question, I promise you. Yes?
So a single number can be a character,
Yes?
but character can never be an integer. Is that right?
A character is represented internally by that magic code, and if you ever try to do math on it, you're doing math on the magic code rather than the thing that's stored in there. So, okay. All right, so we've seen this case. This case is if you give it a bunch of stuff and it tries to parse it and there's not enough, it will just wait, right? It will just wait. Now, how about we do the other thing? How about we give it more stuff than it needs? An int, and then we'll put some other stuff over here. What's going to happen now? Actually, let me rephrase this for a sec. Oh, it'll work. Okay. What's going to happen now with that input? It's going to say, I'm expecting 4 things, an integer, a character, a decimal, and a number, and it will probably just output those 4 things. What will happen to everything else that's in there? It will probably be ignored. And that's what we got. Everybody with me on that? Skeptical? Yes?
Is it always going to ignore the extra?
It is doing something with the extra input. For now, it looks like it's ignoring it. Are you curious about what it's really doing with it? Okay. It is holding it in case there's any more input, but our program ends first. So just like up here where we didn't give it enough, if you don't give it enough, it'll wait. If you give it too much, it'll say, oh, I might need that later. I'll hold on to it. Allow me to demonstrate that, okay? Here's what I'm going to do to demonstrate that. I'm going to take these lines of code that do input and output, and I'm going to double them. So now we're expecting the same thing twice, okay? Now I'm going to recompile. And now I'll run the program again. Whoops. Oh, man. And I lost all the numbers that we used before, but we'll just give it 880, D 0.8, 17, and we'll give it some more integers. Somebody give me an integer. 13. Another character. Caret. A decimal point, 3.14. 31.14, that's good. Another integer, 78. And what we're going to see is that the first time we did input, it found everything it wanted. And then it held everything that was typed for the next time input came along. Everybody good with that? Yes, sir. It would then hang on the second one. because there weren't enough. Yep, so the question was, what if I give it all this stuff, but not the others? It will output the first thing. Now it is holding on to these two values. We could give it another int and character, and it will output those correctly. So it does what's called buffering. It holds the input. If there's not enough, it'll wait for it. If it's too much, it saves it for later. Okay. Everybody good? There's one last thing I want to show you about this. And this is the thing that makes cin your enemy. All right? First, let me go back. I'm going to take out these two lines, the copy lines, because really we only need one line of input to show how bad it is. I will go back and compile. I will clear the screen. Now I will run this program. Let us say that as humans, being imperfect to suck, we enter the wrong thing. We forget the number. What was the order? It was like a floating, it was like a character and then an integer and then a decimal and an integer. Wasn't that right? Yes? It was a character and then an integer, then a floating point and then an integer. Is that correct? No, of course it's not correct. But let's just do it that way because we're dumb. Let's give it an x and an integer, 124, and a number, 3.15, and another number, 90. Any predictions on what this is going to output? Yes, sir. All right. So we know that this x right here, which is a character, is going to be trying to enter to an integer. How many of you think the computer's going to go, stupid human, you screwed up? Nobody? Who's not sure? Yeah, you shouldn't be sure. Here's what's going to happen. When I hit return, it is going to print out 4 values. Are you ready? 12x, 37.92, and 9. Where did those come from? Where did they come from? What? We did. And remember, these are the values that everything was initially set to. These are all the same values that everything was originally set to. Why did it output those? Here's the answer why. Because cin is a quitter. Okay? Cin is going to do its best for you if you give it something you can figure out. But the moment you have something it cannot figure out, it is going to quit. And you know what? It's not going to tell you about it. It's just going to quit. So here's what comes along. It goes, oh, cin goes, okay, I need an int. And somebody gave me, what did we give it? An x. And it goes, is x an int? It goes, I'm done. That's it. If you're going to give me something wrong, I am done. I'm not doing any more input today. So this statement finishes, and nothing gets changed in any of these values. And so when it goes to print out, what values does it use? Whatever was there. Cin is a quitter. If you put the wrong type in such a way that it doesn't work against one of all these weird things that we saw before, it will quit on you. It will give you no warning that it's quit on you. And from then on, no input will ever work again. Ever. Ever, ever. In fact, let me demonstrate that to you. So remember before we had 2 lines of input? Maybe I should have left those there. I'm going to put them back right now. So now we have 2 lines of input, right? We're going to input, ask for input, output, ask for input, output. And let's look and see how that works. We'll recompile, compiled without error, we'll run it. We will give it a type error. We'll give it a character right away, then an int, then a float, then a thing. And here's what we're going to do. We're going to hit enter. What's going to happen now? Yep. Yep. It's going to output the initial, she thinks it's going to output the initialized values, and then it's going to quit. Here's what's going to happen. It's going to output the initialized values twice. Because once cin quits, it does not just quit for that one line, it quits for your entire program. Forever. It just gives up on you and it goes home. Okay? Once cin gets an error, it gives up and goes home, and no more input happens. Yes? You have a question? Yeah. Sure. Yep. Yep. So, and now if we do, something else here, we can see what happened is it didn't revert to the initialized values. It just didn't change anything that we had entered before. So here, once CN broke, whatever was stuck in memory before is still there. It never goes back. But, yes? Halfway through? Yep. Yes, they would. So here's his question. The question is, what if we gave it something correct up front? This was an int, this was a char, this was supposed to be a float, and this was supposed to be an integer. These first two values are correct in type. CN will not break until it hits the x, at which point you will have a combination of stuff we just entered and stuff that was left over. And that's because CN was working, it got the first few done, and then it went, I have no idea what to do with this. I quit, I'm going home. Yes? Once it breaks, it is broken forever. Every single other line of code in your program that uses CN is broken now, forever. Forever. It just will no longer do any input. Now, the question that's occurring to some of you is, that sucks. Is there a way to fix that? Is that what you're thinking? There is, and I'm not going to show it to you. Yes? No. Yes, if you rerun the program, it will fix itself. This is only true on any one run of the program. Yes?
Why didn't it come out the second time with why didn't it come out 5 and
Okay, because this time I didn't create the type error until the third entry. Okay, so we gave it a 12. Is 12 an int? So that one worked correctly, and it now changed the value of int to 12. Oh, well, we can't even 12 because I gave the same value. Sorry. Here, let me give you different values. So 19.3, 24.8. It needs to be an x and 24.8. Right. So what happens, see the first two were correct, and then once the type error occurred, it didn't work anymore. If we look at the code, the first one says, was this an int? It was, so it works, and it says, okay, this used to be 12, and now it's whatever other thing I just said. A letter, was that a letter? Yes. Now it wants to read a decimal, and it gets an x instead. So what does it do? It breaks. So these two worked, but everything through the rest of the program is now broken. Yeah. It outputted things. It got here, and it said, see, and it goes, oh, I'm done. I'm just not going to do anything here, and then it went on. Because it was broken. Once you break CN, it quits. It never does anything again. So if we go back to the values that I entered, I did 19.3x254. So 19, is that an int? 3, is that a possible character? X, is that a possible decimal? So everything from here on out in the program no longer works. It's done. These first two were successful, right? Because they matched. As long as it's okay, it gets through the first through okay. Those will actually be changed. But from there on, CN is broken. When it outputs it for the second time, it uses whatever is currently stored in that box, right? And this one, the box got changed. This one, the box got changed. The others never got changed. Okay? It doesn't revert back. It doesn't have any memory of what it was originally sent to, right? This is like a grinding machine. And the grinder broke halfway through. And this is a horrible analogy, so I'm going to stop. But it's like a dumb machine. There's no, once things are ground, there's no going back. Okay. All right. How many of y'all think CN's your friend? It is. It's just your dumb friend who will do bad things if you're not aware of what they're doing. All right. Everybody happy with this? Whew. Good. Let's take a second to look at my notes. All right. I'm going to save this. I'm going to create a new program. All right. So here's a blank program, and we're going to look at something else now. Change in topic. We're all done with CN. What can we say about CN? It tries its hardest, but it's a quitter. Okay? That's all you need to know. It tries its hardest, but it's a quitter. All right. How many of you are looking forward to a career in data entry? Did you know that there is actually a career called data entry? There is. People send in handwritten stuff, and it's your job to type it into the computer all day long. Does that sound fun? All right. Me either. How many of you are looking forward to a career using stuff that's been entered as data? Maybe not even that either, but it's way better, okay? So cut me a break here. All right. How many of you all, given a file of subject data that has 7 entries and is 18 million line long, wants to type in all that data by hand? No? How many of you all would just rather read it from the file? Yes, I would much rather read 18 million lines from a file than have to type it in by hand. So, how many of y'all are interested in learning to read from a file? I'm trying to motivate file reading, and I'm not doing a really good job today, so cut me a little slack. Okay, we're going to do some file reading. There is a special library that allows us to read from and write to files as if they were C in and C out. Everything we've learned for C out and everything we've learned for C in will work, except instead of being operating on the keyboard, you'll be reading and writing from a file. In order to do this, you have to pound include a library called fstream. Oops. Yeah, I'm sucking badly up here right now, aren't I? Man. Fstream. And I'm not even sure that's right. Let me look at my notes. I believe it's right. Yeah. Okay. So when you include this thing called fstream, IO stream stands for input-output streaming, and fstream stands for file streaming. So we can read and write from a file. All right. There is a trick to doing this. Before we can read and write from a file, we have to tell the computer what the name of the file we are interested in is. Does that make sense? If I tell you, hey, go get data from the file, what would you tell me? What file? Yeah, which is a lot politer than a lot of other answers you could have come up with. But in general, we have to tell the computer what file. So let's create a file for ourselves, okay? What I'm going to do is I'm going to come up with a file, and I'm going to call it data.txt, and we'll have some numbers in here. Let's do 12, 9, x 13.7, okay? And let's do some other things that are similar, 8, 14, question mark, 3.1, 3, and another integer, 0, 9, @ sign, 9, doesn't even matter, 3.2. Okay, so I've just created this data file. It has 4 columns, an int, a character, and a float, or a decimal number. And I've named it data.text, which you can kind of see in the small typeface up there. So now we have some data that we can read. So in order to read this, we have to create something that is called an IF stream and give it a name, input file. IF stream stands for input file stream. We are going to be able to use this in place of cin to get data out of a file. Yes, sir? Cin, by default, is always the keyboard. You can actually change cin to be other things that is outside the scope of this class, and you don't want to think about that right now. But IF stream is something that we declare. This means it's going to be an input file stream, which we can read data out of, and we'll use it just like cin. And I'll show you this in a minute. When we want to have an input file, we already decided that we have to know what? The name of the file, right? So we have to tell input file to go open the file. And this is how we do it. Input file, the name of the IF stream, .open. What is .open here? A method, and we tell it data.text is the file name that we want to read. Yes, sir? Yep. I am declaring this thing. It's like a variable, but it's called an input file. Just like when we use strings, just like we use pound include string, we're able to say string, and then we had strings which did cool stuff. If we say pound include fstream, we can now say use ifstream for input file stream and use that for stuff. Yes, you can have multiple files open at the same time. You will not have to do that in this class. Sure. If I wanted to, I'm not going to do it for this, but I could do, you know, just like I can create multiple variables of the same types, this ifstream, we can have multiple ones. And you'd have to do the same thing with it, yeah. You can do that. We're not going to do that in this class. Probably we're only ever going to have one file open at a time. Yes?
Okay, so if we have the user
Mm-hmm.
input the name of the file they want to read.
We'll get to that. All right? Right now we have this file named data.txt that we created. Yes, sir? It has to be in the same directory, yes, for the time being. All right. So here's how we read a file. We declare an ifstream. First, we pound include fstream. We declare an ifstream object. We say if input file, the name of the ifstream.open, and give it a file name. And now what we can do is before, where we would use cin, we can do input file. We can literally say input file into something. Now, I declared some variables in our data file, which was integer, character, float. So let's do int 1, int 2, and I should make these equal to something. Double decimal. And a character letter. All right. So I declared these variables because these are where we're going to stick things in as we read them from the file. Just like we had to declare when we were doing cin variables to store things, we're going to have to do the same thing here. So here we say input file into int 1, into int 2, into letter, and into decimal. And remember, just like we saw for cin, it'll take these things, use them like a funnel, and shove them on in one at a time, as long as it can. Everybody good on that? Yes? We don't have any errors yet. Okay, let's start with the simple case. It's good to think ahead to like more advanced things, but for now, we have an integer, a character, and a decimal. And if we look at our file format, that's what we had, right? We had integer, character, decimal, integer. Every line is the same and correct. Yes?
So does it know?
No. It doesn't know anything. It's going to do step by step exactly what we tell it right now.
So it doesn't know.
It will. We'll see in a sec. Yes. No, not right now. Is that okay? And it's not that I don't want you to do that. It's just that we have limited time and I want to get through this so that you can use part of it for your algorithm. Does that make sense? Okay. So when I saved it, here's the directory that I'm using for everything in this class. And I actually created the file and just put it in the same directory. So our program is named file.io.cc. We haven't compiled it yet. And data.txt is the text file that we just made up. So they're in the same directory. I'll show you. Just let me go ahead, okay? Everybody okay? Did I confuse you by? Yes, sir. Yep. The only difference between this is that the only difference is that we're saying input file instead of cin, and I'm actually outputting stuff now, so I'm not trying to output to input file. Cout, int1, quote. And I'm just putting some spaces in here so that when it prints out, we can see what printed out. So here's our algorithm now. Create the ifstream object. Yes? Yep. let me ask you a question. So that file had multiple lines. When we had CN and we gave CN more stuff than it needed, what did it do? It just used in order as it read across, okay? So what's probably going to happen here, since input file works exactly the same way as CN does, it's going to start taking it in chunks as we read along. Yes? It is an IF stream. So that's confusing, right? Because we've seen int, character, different types of floats, and Boolean, right? Do you remember when we started using strings? We said pound include string. And from that library, we were able to do strings. IF stream is a special type of variable that represents data coming out of a file. And the definition for that is included in the pound include fstream. Does that make sense? Everybody kind of good now? This input file, this IF stream thing that we've created, is going to work exactly the same way as CN does. Exactly the same way. Except instead of us pounding like monkeys on a keyboard, it's going to take data out of that file. Do you all believe me? Do you want to see it happen? Okay. So here we go. I'm going to compile the program and hope that it compiles cleanly. It did. So now when I run it, what do we expect is going to happen? We can think about this. So here's what it's going to happen. It's going to start at int main. It's going to go along and says, oh, I need an int. What does this do right here? Declares an integer named with initial value of int of int2, initial value of. This declares a variable of type double with a name decimal, initial value 0, character, letter, initial x. This creates an IF stream object named input file. This is the thing that we're going to use in place of CN. If CN is the keyboard, this represents a file. And then we say .open and the file name we want. Okay. And it will go out and find the file in the same directory, open it up. And now when we say input file into it, we'll go, aha, I should be reading data out of this file. It will look at the file we have right here and go, okay, I need an integer, a character, and a decimal. I'll make these bigger so we can see them. Integer, character, decimal, and then it will output those. Right? So if our program works, as I think it might, it should output 12, 9, x, 13.7. If it does something else, I'm probably going to cry. Okay? Just as a warning. Okay, that was close. Now, I forgot to put an end line here, so it got a little jammed up in there, which is ugly. Let's go add an end line, because we don't want ugly output, do we? And we'll recompile it, and we'll run it 12.9x 13.7. Yes? Oh yeah, do the code? Sure. I'll post all this code online today too when I get back to my office. Yes? Ask me after class. The answer is yes. So, and in fact, it creates problems sometimes. You have to get rid of it. Yeah. Okay. The answer to your question is magic. We're not going to do that in this class. Yeah. How are you going to tell it to go on to the next line? So the question is, how do you, we'll worry about that next time, okay? We'll worry about that next class. Just say read one line, read the header line, that's all. Just say read one line, okay? All right, normally when the class gets like this, because I'm rushing ahead, I tend to lose you all. And so I need to stop for a second and just make sure everybody's okay. Are you okay? Sort of? Everybody okay? Anybody not okay? You can admit it. It's okay. I'm rushing a little. I normally when I rush, I start skipping over people's concerns, and then they get run over by the steamroller, and everything goes pear-shaped. So, yes. Yes. Input file, if you give it the wrong type, will break forever just like CN will. Okay? This works exactly like CN, except instead of reading from the keyboard, it reads from that file that we told it to read from. Other than that, it is exactly like CN. Yes? I'll talk about that in a minute. Yes? Sure. You can use input. So instead of read, use input from file. How's that? So instead of read, just say input, because it's in a synonym. Okay. But use input, because otherwise the TAs will get confused. When I grade these myself, which there are actually too many of you to do this year, I am much more lenient as long as you demonstrate the thinking. But the TAs, they're better than computers, but you know they range from imperfect to almost imperfect. Okay. All right. Everybody kind of with us? This is a replacement for CN. All right. So we saw that this worked, right? How about if we wanted to read another line of the file? What would we do? Well, if we wanted to read just another line, here's what we could do. We'll do just what we did before when we were reading multiple lines in the cout using CN, is I just duplicated these lines. Right? This will read one line from the file. This will output whatever is stored in these variables. This will read one line from the file. This will output whatever was stored in those variables. Because remember CN, if we give it more stuff than it needs, it'll save some stuff for later. Input file is exactly the same way. You can think of this data in this file as if we had just typed all this at once into CN, and you know how CN takes it piece at a time as much as it can? Input file will do it this exact same way. So if we wanted to read this file in its entirety, we would need 3 copies of the line. But let me just show you first that this two copies of the line thing works, okay? So we saw that it worked correctly. We read one line, right? Let me recompile now because I have 2 lines, and when I run it, it read 2 lines of the file. Yay, yes. Nope. Nope, it doesn't. To it, enter is just like a space. And I didn't actually demonstrate that very well with CN, but to CN, spaces, tabs, and enters are all the same. They're all the same. All right, everybody with me? How do we read the 3rd line from the file? Great. Oops. All right, so now I have 3 of these lines in here. As you can see, we open it, read 3 lines, I compile it, and I run it, and we read all 3 lines from the file. Okay, now though we're dealing with a very large file. Let's say instead of 3 lines, we have 18 million lines. What do we do? Yeah, well we have 3 right there, so if I double them, I'll get 6, and then 12, then 24, and I just, you know, every time. All right, how many of y'all think it would be absurd to put 18 million lines in there? Yeah, that would suck. It would really suck. Fortunately, if you remember from the early days of class, there is a construct which I will show you briefly and we'll go into more deeply next time. And we drew it on a flow chart like this. It was a decision, but if it was true, if it was false, we went out some way. But if it was true, we did this, right? So we come to reach a decision. If the decision is false, we go off and do something else. But if it's true, we do one statement and then go back and look at the decision we made again. Make sense? So remember here while I said while lines left? What if I put something in here that was the equivalent of lines left? Can't write a question mark. So if there's a line left, we can go down here and we can read a line. And then we could do some computation on it. And then we ask ourselves, is there another line? If so, we go read that one, go back up, read that one, go back up. And at some point, we run out of lines and we go off and do something else. Yes, sir? Yeah, I see where you're going with this, and the answer is yes. But let's just deal with files right now, okay? Okay. All right, everybody kind of see this? Yes, sir. Ah, good question. All right. I'm going to show you briefly how we can do this. God, there's like a number of ways to do it, and most of them are wrong. So I'm just going to show you right now how this works the right way. And this is how you do it. You can put input file into int1, into int2, into letter, into decimal inside the while loop. And in C++, this is a valid check. And what this will say is, if you go to input something and you're able to input all this stuff, you're good. If you go to input something and there is not enough stuff there to read because you're at the end of the file, the file is gone, it will fail. So what our algorithm now is it says declare the fstream object, which is going to represent like cn from the file, open it to a file name that we know, and then while you are reading lines in, this says while every time you read a line in and you output it, go back and see if you can read another line or not. Everybody with me? I know I've been rushed. We'll cover this much more detail next class. I just wanted to try and get this to you for your algorithm. It will never run the same line again. Yep. What'll happen is it'll read a line from here, it'll run this line of code, it will go back up, and we'll say if there's more lines to read, go ahead and read it into these variables, and then run this line of code. Yes, sir? In this case, it is both action and condition at the same time. And the reason I'm doing it this way is you can separate the two, except you can do it wrong. But if you do it this way, it will generally always, for this class, it will always work. How many of you all want to see this actually work in the 1 minute before we leave? How many of you just want to leave? Take my word for it. All right, I'll compile it. Now remember, we only have one output line here, right? Only one. So in the past, how many lines of output will you have seen? Now we have a while loop, which means we will probably see more depending on how many things are in that file. And it was able to get all of them. Okay? Looping is incredibly powerful and incredibly important because programs that just go in a straight line suck, right? The power of the computer comes from being able to do a lot very fast, and looping is what allows us to do things over and over. Most programs have loops within loops within loops. Yes?
So does a while loop need to enter like end statement or
Okay, so the while loop actually ended. The while loop includes these curly brackets. You see those? So this essentially said this is the start of the while loop, and in C++, the matching curly bracket is the end of the while loop. Okay. Yes, but we're not going to do it in this class. Yeah. Yes. But make sure in your algorithm you explicitly mention that you're reading things and what you're reading. Okay. All right. Sorry we're a little rushed today. I shouldn't have done that whole diversion about adding integers to characters, but it was fun for me. See y'all later.